Okay. So, okay, good. Okay, in the last class, towards the end, we had introduced the concept of convexity and concavity. Okay. Now, when we are talking about convexity and concavity, we can use the term to refer to two things. One is sets, the other is a function. So we can talk about convex sets, concave sets. We can also talk about convex functions and concave functions. Now, since in this module we are going to cover functions, by convexity and concavity, we are referring to functions, convex functions, concave functions. And this is actually what we are going to need in a discussion of subsequently in the micro and macroeconomics, mainly in microeconomics. Okay, now first let us look at convexity. Okay, a function f is said to be convex if fx is less than equal to lambda into fx1 plus 1 minus lambda into fx2. What is x? X is lambda x1 plus 1 minus lambda x2. Okay, when lambda lies between 0 and 1. This function becomes strictly convex if instead of this weak inequality, we have a strong inequality. So we are writing the same expression, but instead of less than equal to, we write less than. Okay. So let me discuss this using in a little more detailed. Sorry, there should be. So we start with a function y is a function of x. Y depends upon x. Okay. We take 2 points over here, x1 and x2. Okay. Now, if we look at the function, we're talking about a convex function, convexity. Sorry. This is okay. So corresponding to x1, we have a point over here. Corresponding to x2, we have another value over here. Let us call this a and b. So for x2, we have, if we put x2 in the function, we get, let us say y1, which is f of x1. This is denoted by point A, And if we use x2, then we get y2. This is a function of x2. This is given by point B, right? So this is actually this is y2 and this is y1. Is it clear, everyone?
Yes, sir.
Okay. Achha. Okay. Now we take a third point. Let us call this x bar. And this x bar lies between x1 and x2. Okay. So x bar is located at some point over here in this interval. Specifically, we define x bar as lambda x1 plus 1 minus lambda x2 when lambda lies between 0 and 1. Okay. So let us say that x bar is over here. So for this value of x bar, we have C and we call this y bar. It is denoted by the point C. And please note over here that x bar is okay. Now we connect point A with point B. Okay. Okay. So this is A is, remember A is y1, which is fx1, and B is y2, which is fx2. So basically we are connecting these 2 points. Okay. Okay. And we call this point D. Right. Now D, this point D on the segment AB is given by lambda 1 minus 1 into 1 minus lambda y2. Okay, so we can write this as lambda. What is y1? It is f of x1. And what is y2 but simply f of x2. Okay. Now,
Sir, how did this come?
বাবা, ভয় পাইয়ে দিলে তুমি। হ্যাঁ,
স্যার এই ডি এর এটা দিচ্ছেন না, ওটা কি করে আসলো ওটাই?
না না ঠিক আছে, মানে সবাই চুপচাপ ছিলে, তারপরে হঠাৎ দুম করে একটা প্রশ্ন করলে।
সরি স্যার, মানে
না
বুঝতে
না
পারি।
ঠিক আছে, না 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 ঠিক আছে, ইউ হ্যাভ আ রাইট টু আস্ক। ওকে, এটা কিছুই না, দিস ইজ আ property of mathematics. If you take a point, 2 points on a line, ঠিক আছে, এটা x1 আর এটা x2, তাহলে এই মধ্যেখানে কোন একটা পয়েন্টকে you can represent this in this form. ওকে,
আচ্ছা আচ্ছা
তোমাকে ল্যামডাটাকে জাস্ট ভ্যারি করে দিতে হবে, মানে
আচ্ছা, হ্যাঁ
সাপোজ ইট
আগের
ইজ,
দিন
হ্যাঁ
পড়িয়েছিলেন,
হ্যাঁ
মনে এসছে, এবার মনে এসছে, ঠিক আছে স্যার।
আচ্ছা ওকে। So d is given by, see what is the d is the length of this. Acha, how do we get the length of this? The length is given by এইটা। এটা কি করে আমি দেখাবো? It is given by, আমি একটু শর্ট হ্যান্ডে লিখছি, 1 মাইনাস, এই ফর্মে লিখছি, f1 means f of x1, f2 means f of x2, ওকে। এইখানে ডিটা এখানে আসছে, so that means d will be, d lies within this interval. We can represent this in this form using lambda. Okay, এবারে now tell me তোমার f y bar, ঠিক আছে, f y bar is this, and what is d? d is lambda which is larger,
ডি।
so if the curve is like this, আমরা যে কোনো জায়গা whatever x bar we take, see what is x bar? X bar simply represents the choice of lambda. If we change lambda, x bar will move either this side or this side. So any point over here, this property will be satisfied.
Sir, will that be f y bar or f x bar?
ইয়েস স্যার, আই থিঙ্ক টু ইট উইল বি এফ অফ
হ্যাঁ
এক্স
হ্যাঁ হ্যাঁ
বার।
হ্যাঁ, সরি আমি ভুল লিখেছি। সরি, এটা ল্যামডা হবে।
Sir, what corrections did you make?
This is x bar, not y bar, and over here I had written the value of কি লিখেছিলাম ভুলে গেছি, x bar না y bar, এটা ল্যামডা হবে, আর কিছু না। So given the shape of this function, if the function is like this, we are always going to have this. This will always be satisfied, whatever is the value of lambda. If we choose a different lambda, and I'm just showing you additional different lambdas. We're always going to have this. Right? So these will be point C's. These will be D1, D2, D3, D4. Right? So if you increase lambda, you're going to move here. If you decrease lambda, you're going to move here. But this property is always going to hold as long as the function is like this. Right? Any questions?
No, sir, I can get this point.
Okay. Right. Now let us take a function which is curved like this. So this is x1, this is x2, this is x bar. ঠিক আছে, এটা হয়ে গেল A, এটা হলো C, এটা হলো B, এটা হলো D. Okay, so this is f of x1, this is f of x2, this is f of x bar, and this is lambda f1 plus 1 minus lambda f2. Okay, so again we take 2 points, x1 and x2, and find out the functional value.
So,
Just 1 second. The functional values are y1 is fx, y2. Yes, please.
so is this for concave?
Yeah. This is concave.
Yes, sir.
Yeah. Okay, so we take out the functional values. We take a third point, which is, sorry, x bar, which lies between x1, x2, and we define x bar as lambda x1, 1 minus lambda x2. Okay, so the functional value of this will be right. Then what we do is we take fx1 and fx2, we connect them with a line and find out the point in between. Sorry, I made a mistake over here. Okay, let me just. So if I take x bar, this is actually C. I've reversed the position. Let me just chokkan buje and drawn the copied the earlier diagram. So this is C and this is D. This is f of x bar. And this is lambda f1, 1 minus lambda f2. So now you can see that over here, f of x bar okay, so this is C and D is okay. In this case, which is larger?
C.
C is larger. Whatever the value of lambda, if we take different values of lambda, so these are different values of lambda, you can see that C will always be greater than D. Okay.
Yeah, can you please show this page?
আমি দেখিয়ে দিচ্ছি। In fact, second thoughts. এক মিনিট দাঁড়া, এটা আমি করে তোমাদের দেখিয়ে দিচ্ছি। Yes. Okay. হয়েছে তোমাদের লেখা?
Yes, sir.
হ্যাঁ স্যার।
আচ্ছা, okay. Now let us take what we have done is we have taken curves. Okay, but suppose we take a line like this. So we take 2 points over here. This is and this is the line for x bar. So this is x2, এটা বারটা হবে না, this is x1 and this is bar, this is y1, this is y2 and this is f of x bar. Okay, so everything is the same as before. We have got A, this is C and this is B. Now how do we, what is the point D? Remember D is this, the linear combination of y1 and y2. Okay. So over here, what is the linear combination of y1 and y2? It is this. So here we can see that C and D will be equal. Right?
স্যার
হ্যাঁ,
স্যার বলছি এখানটা সি ইকুয়াল টু ডি কেন বললেন একবার বলবেন স্যার?
দেখো আমরা সি পয়েন্টটাকে কিভাবে ডিরাইভ করছি, x1 আর x2 নিচ্ছি,
হ্যাঁ স্যার।
করে সেটার লিনিয়ার কম্বিনেশন নিচ্ছি,
হ্যাঁ
x বার পেলাম, এটাকে ড্র করে এই লাইন যেই y হয়ে গেল, লাইনটা রিচ করলো, সেখানে কানেক্ট করে দিলাম।
হ্যাঁ স্যার।
আচ্ছা, ডিটাকে কিভাবে পাচ্ছি, এ আর বি নিলাম, এটাকে কানেক্ট করে দিলাম,
হ্যাঁ
ঠিক আছে, সেই সেগমেন্টটা এক্স বারে, সেই সেগমেন্টটাকে এইভাবে লাইনটা টেনে আমি এটা পাচ্ছি।
হ্যাঁ স্যার।
ঠিক আছে, এখানটা দেখো আমরা কিভাবে একটু বড় করে দিচ্ছি, আমি স্লাইড শোতে যাচ্ছি, এটা ভালো করে দেখো আমরা কিভাবে করছি। এক্স বারটা নিলাম, যেই ফাংশনটা টাচ করলো সেটাই হয়ে যাচ্ছে আমার ওয়াই বার। ওকে,
হ্যাঁ স্যার।
হাউ am I getting D? A and B কানেক্ট করলাম, এই লাইনটা, দিস লাইন, এক্স বার টাচেস দিস লাইন, ঠিক আছে,
হ্যাঁ
সেইটাকে ড্র করলাম।
হ্যাঁ
এখানেও দেখো একই জিনিস, এক্স বার ফাংশনটা টাচ করছে, ওটা হচ্ছে এফ অফ এক্স বার, এ বি
হ্যাঁ
সেগমেন্টটা নিলাম এখানে। এখানে কি হচ্ছে, এখানে তোমার ফাংশন আর সেগমেন্টটা তো সেম হয়ে যাচ্ছে,
হ্যাঁ
বুঝতে পারছো, ওয়াই অফ এফ এক্স আর তোমার এ বি যে সেগমেন্টটা, এই দুটো কোইনসাইড করছে,
হ্যাঁ হ্যাঁ স্যার।
সেই কারণে সি আর ডিটা সেম হয়ে যাচ্ছে।
ঠিক স্যার, থ্যাংক ইউ স্যার।
আচ্ছা, তাহলে এইখানটা আমরা কি দেখছি, f of x bar is equal to lambda f of x1 1 minus lambda f of x2. ফাইন। তাহলে আমরা দেখছি we have got 3 possibilities over here. দাঁড়া আমি পাশাপাশি লিখে নিই, তাহলে আমার একটু সুবিধা হবে। নো, আচ্ছা ঠিক আছে। আচ্ছা এইখানে তোমার সি আর ডি এর মধ্যে রিলেশন কি?
Can you please show this graph at the C equal to D graph, because I could not write down everything, the equations. Yes, thank you, sir.
এখানে যে লাইনটা এটা আসবে না কিন্তু, হ্যাঁ এটা আমরা একটু আঁকতে গিয়ে লিখতে গিয়ে
Which
বলে
line?
এই এক্স টুর ওপরে এই যে লাইনটা রয়েছে এটা আমার জাস্ট দাগ পড়ে গেছে। দিস উইল বি x1, দিস উইল বি x bar, দিস ইজ জাস্ট x2।
Oh, that is x2, not x2 bar. Yes, that I know.
হ্যাঁ হয়ে গেলে বলো প্লিজ।
And thank you, sir. It's done.
আচ্ছা, now look at this carefully. What do we have over here? What is the relation between C and D?
C is less than D.
আচ্ছা, over here
C is greater than D.
and here C is equal to D. আচ্ছা, so over here C is equal to D, এখানে
C is less than D.
C is less than D and here C is greater than D. Okay, so we call this strictly convex. We call this strictly concave, right? And how do we classify this? This can be either part of, if we just extend the definition and consider the case of this, then a function like this or a function like this, it becomes what we call convex. Okay, C less than equal to D. Instead, another alternative is we can define this, take these two cases, C greater than equal to D. This is concave. So we are removing the strict term, this qualifying term. If it is a strict inequality, it will be a curve like this. But if it is just convex or concave, we can include this linear function in our definition. Is this clear?
Yes, sir.
অত দুঃখের সঙ্গে বলছো কেন গো? Okay.
না স্যার, দুঃখ না।
ঠিক আছে। If you want to go for a non-technical definition, convexity means that the segment lies above the function. Okay. The function lies, or you can say the line, the function lies below the segment. See, the function is lying below the segment. This is the segment, you're lying below this. Over here, you can see that the function lies above the segment. Okay, so this is a non-technical definition. Okay, is it clear, everyone? Okay, now we come to the concept of a level set. What is a level set? Let me show this using a diagram. Suppose we take different values of x. Okay. So we have x1, we have x2, we have x3. And what is happening over here? So we have taken x1 greater than x, less than x2, less than x3, and we can take other points also. Corresponding to x1, we have, let us say, y1, y2, y3. So what happens is, again, there's a relation like this. If we take a negative function, what is the relation? Implies y1 will be greater than y2, greater than y3, and so on. Okay, the ranking for y reverses. We call this a negatively sloped function. Sorry, we call this a positively sloped function, and this is a negatively sloped function. Okay, but the important thing to note is, as x is changing, the value of y is changing. Okay. Now, let us suppose that the function that we have drawn is like this. Okay. So if we take points like these, if we take points like these in this range, if we take x2 which is greater than x1, we are going to have y1 greater than y2. Here again, if we take x1 greater than x2, y1 will be less than y2. But over here, let us take different values of x. What happens?
Sir, x increases but y remains constant across this patch.
Very, very good. So over here, what we have, we are taking different values, but the value of y remains same. y1 equal to y2 equal to y3. The functional value remains the same. This is called the level set. It is the portion of the function where the functional value remains same even when x changes. That is for different values of x. You have different values of x, but the functional value remains the same. Okay. না এটা তো বেশি মোটা হয়ে আছে আচ্ছা actually level sets if you take a function which is of one variable, it may not always be possible to identify the level set. If you take the functions that we have looked at before over here, either this black one or this green one, will it have any level set?
No, sir. It is constantly. I mean, x and y
Changing.
are both varying with each other.
How? It may be y may be increasing or y may be decreasing,
Yes, sir.
but it is not going to remain the same. So this is a level set of a one variable function. But in general, identifying such functions are pretty difficult. It is easier if we take two functions like this. So now we are saying that y is a function of x1 and x2. Okay, it's not a function, it's not one variable function, multiple variable function. Okay. Let us see, M is income. P1 and P2 are prices, and X1, X2 are the amounts consumed. Fine. So what is the meaning of P1 into X1? This is the expenditure on the first commodity. This is the expenditure on the second commodity, right? So if we add the two, we get expenditure, right? This is the expenditure by a consumer. Okay, I'm coming back in 1 minute, please. Okay, so this is the expenditure. Yeah, so this is the expenditure by the consumer, and M is his income, right? Now, what is the relation between income and expenditure? We normally assume P1 X1 plus P2 X2. Okay, so suppose your income is 100, P1 is 2, P2 is 4. So what is this equation? At this moment, let's forget 100. Okay, so we have M is equal to 2x1 plus 4x2, right? Now, let us draw this function for M equal to 100.
Sir, is this the budget line?
Yes, this is what we call the budget line of the consumer. Okay. So what are the values of x1 and x2 which will satisfy this equation?
Sir,
Huh.
sir, then the whole thing that M equals to 2x1 plus 4x2 is known as the budget line.
Yes.
Acha, sir.
Just give me 4 or 5 points. I think this will be easier.
Sir, x2 in terms of x1.
Yeah, you can do this. So x1 is equal to 100 minus 4x2
Sir,
by
we can
2.
also get the intercept forms by dividing both sides with 100.
হ্যাঁ, ঠিক আছে, যাই হোক x1 আর এটা এই ফর্মে নিয়ে এসো। So put in a value of x2. Let us say x2 is equal to 2. What is x1?
$46.
So 46.
x1 কি 46 হবে? কিছু একটা ভুল হয়েছে দেখো তো এখানে।
Sir, that should be 4.
Which one?
Oh, no, sir. No, sir.
ঠিকই আছে মনে হচ্ছে, কারণ 2 দিলে তো স্যার
So it's correct.
50 minus
হ্যাঁ
4.
এইট হয়ে যাচ্ছে হ্যাঁ দিস ইজ 92 হ্যাঁ আচ্ছা একটু লেটস টেক আ লিটল বিট হায়ার 12 so this is 24 x1 will be 26 এটা কত
Sir,
হচ্ছে
two.
এক মিনিট দাঁড়াও
Sir, 2 হবে।
sorry yeah so we have for different values of x2 we have different values of x1 so we have different combinations 46 2 26 12 52 24 so if you put in different all these combinations in this function
Sir,
yeah
Sir,
Sir,
লাস্টেরটা
it is at
24 আর 2 হবে।
Yes, sir, 24 or 2.
ওটা ভাগ করা হয়নি okay so if you put in these values into the equation we are going to get the same value of n okay accept it that if you plug in these three values there are also other values we are going to get the same value of n and we can represent this in terms of this is the linear function so this will be the equation right this is an example of a level set so you start off with a y is a function of x1 and x2 and you find out the different combinations of x1 and x2 which will give you the same value of f. So let me use a different color. So we have different values over here. All this will give me the same value of y. Okay. So this will generate a level set. It's also possible to derive a level set for the one variable case, but in a y variable case, you can't always find out the level set. It depending on the nature of the function, it may not be possible to derive to get a level set. But if you take two or more than one function, it's possible to find out combinations giving you the same functional value. So I'll just write it down over here. The level set shows the combinations of x and x2 that yields the same functional value. Okay. It's also possible to think of other. It's also possible to think of other examples of level sets. If you look at consumer theory,
Sir, in indifference curve,
yes. See, suppose your utility is a function of the amount that you consume. Suppose you are consuming two commodities. Okay. So the more you consume of x1 and x2, the more you get utility. Okay. Now suppose you increase x1. What will happen to utility?
So initially it will increase.
It should increase. We are talking about normal commodities. And suppose we reduce x2. Then what will happen to utility? It's going to come down, right? Now suppose the increase in utility exactly balances the decrease in utility. So I start from here and I increase the amount of x, right? Utility increases. So I reduce the amount of x2 so that utility falls, and these two balances. So that means the utility levels over here in these 2 points, A and B, are going to be same. So if I connect them, I'm going to get what is known as an indifference curve. Okay, so it is represented as u bar x1, x2. We are keeping u bar constant. So we can draw different utility. So this is for, let us say, u1. This is the level set for higher levels of utility. And this is a third level set where the utility level is even higher. So you have 3 level sets over here. Obviously, you can draw even more level sets. There are level sets in between, below this, above this. And if you consider all of them, they are called indifference maps. Okay? But any one curve is called the indifference curve. So this is not a utility function. A utility function is simply this. If you increase consumption, utility goes up. Here we are keeping this constant. Keeping this constant, we find out the combination of x1 and x2, which will result in the consumer getting U bar. We can think of other level sets for production also. Let us say,
Sir,
huh,
so once can you show the previous slide?
Sir, there can be another example of this level set. Sir, can production possibility curve be considered another such example?
Done, sir. Thank you, sir.
yeah. Yeah, I'm coming to the production cases now. Q is a function of L and K. Okay. So that means if a firm wants to produce something, the firm uses labor and capital. If you increase just labor, output will go up. If you increase just capital, output will go up. If you increase both, then also output will increase. Okay. But suppose we increase labor, which implies output will increase, but we also reduce capital so that output decreases, and these two balances so that del Q is 0. Okay. In that case, we find we'll get a curve like this, where output is, let us say, Q0. So these represent different combinations of L and K, combinations of labor and capital, where output is equal to Q0. This is called an isoquant. Okay. So we write this as Q bar is equal to QLK. Or you can put F over here, whatever. And again, if you want to take higher levels of output, you can always do so. So this is for Q0, this is for Q1, this is for Q2. You have an isoquant map. Fine. So we have production, we have consumption, we can draw level sets for either of them. Now the case of production.
Can you please say what is isoquant?
Sorry?
Can you please say what is isoquant?
Isoquant is the combination of labor and capital. It's a curve which denotes the combination of labor and capital such that output is constant. Output is constant at, well, it depends. It can be Q0, Q1, whatever. So I just put Q1. Okay, so it's a level set for production. Okay. Now, what is the expenditure? Suppose when the firm uses labor and capital, neither of them are free, right? Neither labor nor capital are free. So let us denote W as wage, the price of labor, and let us denote as R. We can call R rental or interest. This is the price of capital. So what is the expenditure? What is the wage bill? What is the expenditure on workers? It is given by WL. And the rental or interest, the expenditure on this is R into K. So the total expenditure is given by WL plus RK, right? So we say the cost of the firm, the cost incurred by the firm, C, is equal to WL plus RK. So if you go on increasing L, cost will go up. If you go on increasing capital, cost will increase. If you increase both labor and capital, then also cost increases. But suppose we have a fixed budget. Okay, C bar equal to WL plus RK. In that case, what do the different combinations of L and K represent? If we solve this equation, we will get different combinations of L and K that results in the same cost to the producer. So suppose we have prices, let us say the price.
Excuse me. You are denoting rental with like what is written before K.
R, yes, R is interest or thing, whatever, মানে এখানে ইন্টারেস্ট করবে, আমি আগে যেহেতু ইন্টারেস্ট লিখেছি, রাইট ইন্টারেস্ট, ঠিক আছে?
Yes, sir.
So the labor and capital that results in the same cost to the producer. So this is also an example of a level set. We call this an isocost. This is equivalent to the budget line of the consumer. It represents the budget line of the producer. So isocost is the budget line of the producer. And how do we draw it? We can again draw it for different levels. So here it is C1 WL plus RK. This is C2 is equal to WL plus RK when C1 is less than C2. We can draw other isocost lines over here also. Is it clear, everyone?
Yes, sir.
Okay. Now, one of you mentioned production possibility. Presumably, what you're saying is the production possibility frontier. So actually, over here, we write this as an explicit form. This is not an implicit function. Something like this. This is y, this is x, and what you have over here is the combinations of x and y that can be produced using the given amounts of labor and capital. So over here the problem is, what is the functional value? বুঝতে পারছি আমি কি বলছি?
Yes,
Over
sir.
here you're choosing these two axes on these two axes so that your value of C is constant.
Yes, sir.
Here the value of Q is constant. Here the value of U is constant. But here what is constant? So this is not, I don't think it can be called a level set.
Okay, sir.
So this represents the combination of X and Y, the combination of goods that can be produced using resources available to the country, and obviously given technology also. Okay, because if the technology changes, the PPF, what we call it, will move out. Okay. Okay. Okay, now this is a better set. Okay, so all of you understand what is a level set?
Yes, sir.
Yes, sir.
Okay, now we come to a better set. See, if you go back to the utility theory, the indifference curve, what we have over here along this, your utility is constant at u equal to u0. Okay, so these are different combinations of x and y which will give you u0. Let me indicate 2 points over here. Right? Now, consider a point like this, a point like K, a point like L. What is the utility level over here? Is it U0 or is it higher?
Sir, but I think it will be higher because it is out on the right hand side. It is the outward region, so the utility must be higher.
Okay. So if we take points like K1, K2, K3, the utility level is higher. But if we take points over here,
Sir, it will be lower, sir. The utility will be lower.
utility level is lower. Okay. Sorry. So the better set is that if you put in the functional values, okay. I'll just take 1 point over here. So this is a combination. ধরো এটাকে আমি for simplicity I'm writing this as y and x. So this is y1 and this is x1. Okay. And I'm taking another point which is y2 x2. Okay. আচ্ছা. So the combination of we can write this. Right? The utility over here is greater than the utility over here. So we can define a better set as the set of points, the group of points, which will give me a functional value which is at least equal to u0 or more. So that means if you take this function, all these functions are equal, the points over here will give me a higher level of utility. So over here, I have equal utility, points over here is higher utility. And what are points over here?
Lower utility.
Lower utility. So if I look at this part, this is called a better set. And if I look at this part, it is called, sorry, not a lower set, it is called a worse set. So that means if I take a combination and it gives me a value of f, a functional value y, which is at least equal to my original value, then it belongs to my better set. Sorry, just one second. Hello. Okay, they have called to give me a credit card. So should I respond or not?
Sir, you shouldn't. I think these are fraud calls.
I don't know. I mean, when I've spoken with them and I asked for cards, they generally refuse.
Oh,
একটুখানি বলতে হয় যে চাকরি চলে গেছে, একটু অভাবে আছি,
হ্যাঁ স্যার,
তারপরে আর কিছু বিরক্ত করে না।
হ্যাঁ স্যার, এরকম বললে স্যার নিজে থেকে রেখে দেয়।
হ্যাঁ, ঠিক আছে, ছেড়ে দিই, ওকে, ক্ষমা করে দিই আজকে।
হ্যাঁ স্যার।
তো যেটা হচ্ছে, so what we see over here, that if you take points over here, including this line, if you take combinations of x1 and x2, the corresponding value of y will be greater than equal to the original value. Okay, so I can write it like this. The original value is sorry, let us say x0 y0, this is the original value, and the new value is x1. So if I have this, so all points x1 y1 which satisfies this condition will give me the better of set, the better set, and the worst set is the opposite. All values of x1 and y1, all combinations of x1 and y1, which will result in a utility which is at most equal to my original value. At least equal to, it may also be less. And again, if I stay the strictly better set, it's a strong inequality. Strictly worse set, it's a weak inequality. Okay, so over here you can see this is a weak inequality. Sorry, this is a strong inequality. So all the points on the gray section, not including this, yes, greater than, better off than if you're at C2. And if you're the point x0, it's same. Here also you can see that this gray part, you're at least greater than or less than the original value. Okay, so in a similar way, you can define the verse of set. This is the original functional value is less than equal. Sorry, you are taking a new point, and this new point has a functional value which is less than or equal to the original value. Okay. Then I come to something which we call quasi concavity. We look at the better of set. If the better of set is a convex set, right, then we say that the function is quasi concave. And if the better of set B is strictly convex, then we say that the function is strictly quasi concave. Okay, over here, can you tell me whether it is convex, whether it is quasi concave or whether it is strictly quasi concave?
Sir, this part I can't understand actually.
Okay. Okay, this is a set and we are taking a point like this, right? X2, X1. Achha. Now, what is the better of set? The better of set is this part.
Yes, sir.
Sorry, I'm using the word better of, but it's actually better set. Okay. Now look at the better set. If the better set is convex, then see there's a function. This is a function. Then the function y, which is a function of x1 and x2, is said to be quasi-concave. Okay. If the better of set is strictly convex, then the function is said to be strictly quasi-concave. See over here, if you take 2 points and you connect them, will they lie on the better of, um, will all the points connecting these lines lie within the better of set?
Yes, sir. They will lie on the better of portion only.
So tell me, is this set convex or concave? What is the definition of a convex or concave set? What is the definition of a convex set? Remember, convex set is defined as we take 2 points in the set, we take the line segment, all points on the line segment will be within the set. Right? And what is a concave set? Can you tell me what is a concave set? Just use this definition.
Sir, it will
Yes, sir.
it
You
will
told, sir. Sir, all the points on the line segment will not be inside the set, sir. You showed by showing one donut shape set, and one line segment through it
All points on the line segment may not lie
inside the
within the set.
yeah.
I'm just asking you that what do we call this set over here? Is it also a better set? If I come over here, what will happen to this value of y?
Sir, it will decrease, sir. It will be a worse set. If it comes downwards, then it will be a worse one.
Okay, well, is this worst set convex?
Yes, sir. It will be convex.
Convex.
Yes, sir. All the points of the line segment are lying inside the word set, so I think it will be convex.
Sure.
I'm not sure, sir. I'm not sure, sir.
পয়েন্টস গুলো তো এখানেও লাই করতে পারে.
Sir, could you repeat it once more?
What I'm saying is, asking is that is this verse set convex or is this verse set convex?
No, sir.
No, sir. If the line is lying on the upper part, then yeah, it is cutting off it. Then
Yeah.
yeah.
So if I take a point like this, it appears to be convex. All points lie in the within the set. But it's also possible to take points like this.
Yes, sir. Then it will not be convex. It will be concave.
Yeah. So remember that you cannot choose just 2 points. You have to choose all points and show that any 2 points, the line segment connecting any 2 points has to be within the set. So this verse of set, this is concave. And this better set is convex, right? Whichever point you take these points, take this, take this. You always, all these points, all the line segments lie within the set, right? So, suppose we have a situation when the better of set is convex, then the original function is said to be quasi-concave. So I'll just keep this and then I'll go to a case when this is not true. Now, suppose we have a function like this. Okay, so that means as we are moving up like this, utility is increasing. So where will the better of set lie and where will the worse of set lie? আমি
Sir,
এখানে
better.
নতুন করে এঁকে দিচ্ছি তাহলে so that you don't get confused. Yeah.
Sir, upper part is better of the, and the lower part is for the words set.
Okay. Right. So this is almost the same as in the earlier case, only the
Yes,
nature of the curve has changed. Right. Now
yes, sir.
tell me, is the better of set convex or concave?
Sir, concave. Sir, because sir, a line drawn from the narrow, sorry, corner part. Yeah, this type of line, it is not being covered entirely by the set.
Very. In case of the verse, sorry. In case of the verse of set, however, it is within the set. So verse of set is convex. The better set is concave. Okay. Okay. So we have defined quasi-concavity. Now let us define quasi-convexity. The verse of set, if the verse of set is a concave set, then the function is said to be quasi-concave, convex. Okay, and obviously the strictly. The strict part is, I mean, you just have to drop the inequality part. So what I'll do over here, I will, let me copy this. এইটা যেটা আমি আগে বলেছি এটাকে আমি আগে ড্র্যাগ করে দিচ্ছি। Okay. So I've just copy pasted them together. This is wrong. So I'm just comparing the definitions. Fine. So in the next class, I'm just saving it. Okay. So please go through the definition. Achha, when you're going through the definition, page 55. Okay, you will see that there's a definition 2.29 of quasi concavity. Okay, after that, you will see there's a discussion on, it says something like this. The terminology, okay, it's better if I show the portion to you. I think that will be easier. All of you have copied it? May I exit this PowerPoint?
Yes, sir.
I'll show Hoy's books, otherwise you're going to get unnecessarily confused. Achha, have you downloaded Hoy's book?
Yes, sir.
Okay. So download it now and use it, but try to buy Hoy's book and Chiang's book, both of them.
Sir, I have bought it.
ठीक है, very good. Okay. So I'm asking you to read from this portion. Concavity, convexity, quasi-concavity. You see that you have definitions over here. The function is convex, before this concave, so on. Level set. Now you start off with quasi-concavity, beta set. Okay, now over here, page 55. Read only up till this. Over here, particularly over here, the terminology in use here may be confusing. Why quasi-concavity when the relevant set must be concave, convex, etc. Don't read it now. Okay. So this portion, don't read it. I'll explain this in a separate class. In the next class, I'm going to discuss some problems. After that, I'm going to come into this, the relation between convexity, concavity, and quasi-convexity, concavity. Okay. Then in the last part, they are again starting to define the verse set. Read this also. Again, this line, these two lines, just drop it. Okay. You have the definitions, that's fine. These parts I'm going to explain in a subsequent class, if possible, Tuesday, otherwise, whatever, Friday, whatever. So, don't read it now. If you read it, you're only going to get confused. This part I'm going to teach from Chiang. I'll explain this in a separate class. Fine? Is it okay with you?
Yes, sir.
Yes,
Okay.
sir.
Okay.
So,
Yes, sir.
ঠিক আছে? So I'm ending
Yes, sir.
today's class.
Yes, sir.
Thank
So
you, sir.
when is the next class? Tomorrow?
No, sir.
No,
Wednesday.
not tomorrow. Wednesday. Okay, we'll meet on Wednesday then.
Thank you, sir.
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 Thank you, sir.